Right here, 12. We're looking at the next topic here, which are nonlinear relationships, and we're going to start off with the quadratic function. We've seen this a little bit before. Now, quadratic functions essentially have an x squared in them. Right? It's the simplest thing. There are a couple other conditions. First of all, I want to talk about linear functions again. Right? We've dealt with these before. These are straight lines. We often express these in the form y equals mx plus b, where m is the slope or steepness of that line, and b is the y-intercept. Okay, so m is the gradient, the slope or steepness, b is the y-intercept. Right? This number here tells me where I cross the vertical axis. This number here, if it's a positive, it goes up. If it's a negative, it goes down. If it's a large positive number, then it's got quite a steep slope. And if it's a sort of a large negative number, like -10 or something, then it goes down quite steeply. Those properties are going to have some similarities to the properties of quadratics. So, if I have y equals some lot of x squared, maybe plus some x's and a constant, okay, but an x squared, no x cubes or x to the 4s, no square roots or 1 over x or 1 over x squared or anything like that, no y squared, anything more complicated than that. Y equals x squared, or a variation, is a quadratic. Now, the shape of this curve, when I graph it, is called a parabola, and these have useful practical applications. And if I kick a football, then the path that that ball follows through the air is pretty close to being a parabola. A satellite dish or the headlights in your car are based on parabolas as well. Now, the most basic form of this curve looks like this. So y equals x squared. Right, it's symmetrical about the y-axis, which we should label, passes through the origin. We say this is concave up, right, because like a cup, it points up. Now those sides become very steep, but they're never vertical. And that's the first one, that's y equals x squared. Now, y equals negative x squared. What really happens here is we reflect it about the x-axis. It gets flipped upside down, right, it's negative, goes down like this. Right, again, through the origin, becomes steep. That's y equals negative x squared. Some people like to remember this positive and negative. You put little eyes on here, right? Yeah. And that looks sort of positive, like a smiley face. Yeah, that looks like a sad face. If that helps you to remember, that's wonderful. Positive and negative. Now I'm going to say this is concave up, and negative x squared is concave down. Righto. Next up, what happens if I do this? Well, think of what happens to y equals x plus 3. It's like the graph of y equals x, but it's been moved up 3 units. Now, this is the same. I've got the y equals x squared, but moved up 3 units. Right, so like this. It's y and x, and of course that passes through 3 there. Now this low point here, where it comes down and turns around, we'll call that a vertex. Right? I've got a vertex here and here and here. Sometimes it's a minimum, sometimes it's the maximum point for that curve, depending on whether it's concave up or concave down. The coordinates of the vertex for these two graphs is both the origin, 0, 0. The coordinate of the vertex of this graph is 0, 3. Now, x squared minus 2, right, it's still concave up, right, it's just that it goes down here. Right. So that's negative 2 there. That's my x-axis and my y-axis. So this time the coordinates of the vertex are 0, negative 2 here. Now sometimes we should work these things out, but in this case I don't particularly mind. We'll leave those for the time being. The graph of y equals x squared plus c, the c part moves the graph up c units. Right? C is negative, it goes down. If it's positive, it goes up by that many units. Moving along to a couple of other cases here. Now, 2x squared. Remember that if we have something like y equals 2x, it's steeper than y equals x. 2x squared, steeper sides. Oops, that's not right. Hang on. Right, so it'll rise fairly quickly like that. Whereas half x squared, right, still concave up, still passes through the origin, has the same general sort of shape, but wider, broader. So if the number is larger than 1, the graph will be narrower and steeper. And a fraction will make the graph wider and less steep. Okay, it's still very steep on the sides. I don't particularly like the shape of that curve. I'm going to redraw it. Now there is certainly a skill to drawing these things, and you are expected to sketch them fairly neatly. That's not fantastic, but nonetheless we get a general idea. Now, we talked about vertices before, so x squared, positive x squared, concave up, then the vertex is at the bottom, it's a minimum point, right, and the reverse for negative x squared. Now, table of values. If we're to do this, it probably helps to, right, let's have a look. I'm going to have x values of -3, -2, -1, 0, 1, 2, and 3. Y values we have to work out. Okay. It tends to be easiest to start with 0. So here, if I put 0 into that, then y would equal 4. If I put 1 in there, 1 squared is 1 times -3 is -3. 4 minus 3 is 1. 2 squared is 4 times -3 is -6. 4 minus 6 is -2. 3 squared is 9. By -3 is -27. 4 minus 27 is -23. Is that right? 4 here. Oh, now I've got a mistake here, don't I? What happened there? What happened to my 2? 2 squared is 4. 2 squared is 4. -3 times 4 is -12. 4 minus 12 is -8. Right, and that's negative. What happened here? I said that was 27. 4 minus 27, -23. Now, moving back the other way, -1 squared is 1. 1 by -3 is -3. 4 minus 3 is 1. Now, we're going to see a certain amount of symmetry go on here because when I square a negative number, it becomes positive. Okay, so I'm going to get a -8 and a -23 here as well. Right, now we're going to draw this. Actually, can I give you a tip? I much prefer to draw these with drawing the curve first. All right, so my curve is concave down, like this. Right, you can see that if I draw that without trying to make it go through certain points, yeah, I certainly get a better looking curve. It's not perfect, but it's better. My axis of symmetry is down here. That's my y-axis. And you can see that my vertex is at 4. Crosses over something like this. I'm just going to draw this. X, Y. Now I know that it crosses up here at 4. And it's going to cross the x-axis somewhere between 1 and 2. Fairly close to 1, but somewhere between 1 and 2. Right, that's all we really need there for the time being. I could put some points on there, but we get the idea. Righto. Now, the video is getting away from us here, but there are some more things to do here. We are going to graph this and find its vertex. Right. Are we going to draw up a table of values? No, I think we're just going to graph it. Now, it is a positive x squared, so it's concave up. And the vertex is at 0, -1, but nonetheless concave up. Because it's a half, it's a fairly wide looking thing like this. And it crosses at -1, so my axes probably go across here like this. There's x, y. It's not quite right there, but anyway, of course, the minimum part should really be, and if you are asked to sketch these things in a test situation, well, you've got to get some of those properties right. Right, it should be symmetrical. That's a bit better. A ruler, of course, helps, but anyway. So that's -1 there. There we go, there's our sketch. I'm not going to put in those intercepts there. So they're quadratics. Remember, they have an x squared term. If it's positive x squared, it's concave up, right, like a smiley face. If it's negative x squared, it's concave down. If I have 2x squared, it's much steeper and narrower than half x squared. And a constant on the end, right? X squared plus 3 lifts it, the whole graph up 3 units. X squared minus 2 will drag the whole graph down 2 units. Righty, I'll see you in class.